Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from the IoT Builder perspective. Today is May 3rd, and this is episode 27 of our weekly live stream. My name is Nenad. I'm a senior developer advocate for AWS IoT, and I'm joined by my colleague and co-host Alina. So, hi, Alina.
Hi Nanat, how are you?
Yeah, all good, all good. You
Yeah,
want to
same
introduce
here.
yourself?
Yeah, absolutely. So, my name is Alina. I'm a senior developer advocate in the AWS IoT team, and I'm looking forward to the discussion today.
Yeah, me too. I mean, today we are going to talk about mysteries and challenges of roller coaster rides of debugging constrained devices in the context of IoT. So, and for this special event, we have Tyler from Memfold. Uh, Hi, Tyler. How's it going?
It's going great. Yeah. Very excited to be here.
Excellent, excellent. So maybe we can start with you introducing yourself. So for the audience.
Cool. Yeah. I'm Tyler. I guess I've been a firmware engineer for about 9 or 10 years at this point in time. Worked at a company called Pebble, which made smartwatches back in 2012, 2014. They kind of rose from Kickstarter. And then worked at Fitbit for about 3 years as a firmware engineer / firmware developer tools, I would say. And then about 4.5 years ago, started Memfault with a couple other firmware engineers from my days at Pebble.
Nice, nice. This is pretty cool. So, I mean, the first thing that I'm interested in is like, why was Memfold created? Like, what was the issue that you saw, and you said, okay, this needs to be solved on a higher level.
Yeah, for sure. As firmware engineers at Pebble, back in, I guess I joined in 2014, but they had the trouble since 2012 since they started. These devices were running a Cortex M3 at the time, with probably about 100K of RAM, or on that order of magnitude. Everything was written in C. It was probably one of the first devices to connect to an iPhone to pull off notifications. Like when Pebble was started, there was no notification service on Apple. It was kind of built for them to support the notifications, it seemed like. And we tried to do a bunch of other things at Pebble, like third-party SDKs. People could write applications. People could try to crash the watch in every way. They could exhaust all the resources. They could continuously pull from the accelerometer. There's so many things they could do, and so many ways they could exacerbate bugs. And also just like a Bluetooth stack and a bunch of other things that were incredibly complicated. The hardest thing at Pebble was probably debugging, I would say. As soon as you get firmware onto a watch that's sealed and it's away from your desk, we had no idea how these things were crashing, what led up to a crash, what caused a Bluetooth bug. And so we kind of had to build everything from scratch, even though we didn't want to. And so everything from printing, I mean, people know, everything from printing logs to the screen, to saving logs to Flash, to pulling off core dumps, to sending up battery life metrics to a data warehouse, like all of that was built in-house. By a bunch of firmware engineers, honestly. And so you could probably imagine that it wasn't super scalable. At least all the first revisions were built by firmware engineers, and they were built, for local tooling, and nothing was kind of in the web at that point. Nothing was easily usable, but we had them, and it was great, honestly. It worked quite well. And the tools that we built at Pebble, we obviously improved them. A lot of them turned into web applications. And so not just firmware engineers could use them. Support team could use some tools to view metrics over time to kind of assess how a device was failing, kind of on a graph view. Our product team knew how good a release was due to on their dashboards that we had kind of created from their queries that they were running on the data overnight. And it was honestly just great. But again, like, we wish we could have just bought the tools at Pebble. There was no reason to spend all of this engineering time building these things. And honestly, we had kind of assessed and concluded that we just couldn't find the right Google search. There was no way we were doing it right. There was some enterprise or some company that we hadn't been reached out to, or we hadn't yet found on Google. We had some of them had reached out to us, And when we showed them what we had, they were like, "Oh yeah, you guys are way further than we're talking here, and you guys just keep doing your thing." It was actually really fun. Those companies existed a while ago.
It's funny that you mentioned it. The firmware engineers build out something that's that advanced. But yeah,
we had great people. I think that was also one of the fun things from Pebble.
nice.
And a lot of our firmware engineers, I think, just came from software, and they were just very excited to work on the Pebble firmware. It was honestly great. A bunch of us went to Fitbit, to Intel, to Oculus, and kind of just realized it was the same problem. Like, all these companies were building things internally. We would have loved if Fitbit, one of the more successful firmware companies, had just bought a tool or acquired a company or something like that. But no, it's just like continuously building these things internally. Again, all built by firmware engineers, but not quite with the like usability and software aspect that we had at Pebble. And so everything was still kind of done locally. Only a couple engineers knew how to build the things or run the things and debug certain watches. And it also wasn't as featureful. Anyways, we wanted to solve, me, Chris, and Francois, when we started Memfault, we had kept dreaming of what if this was solved for, I guess, the entire hardware industry? What if Pebble didn't have to create it? What if all the smart locks and all the smart watches that were coming out in the future didn't have to worry about this problem? And so that's kind of, I guess, the forcing function of Memfault. And so we started it back in 2019. We all bought laptops and started working on it in 2019, and then here we are. Nice.
That's a pretty cool story. I mean, you felt the pain, and then you wanted to create something that you can relieve this pain to other embedded firmware engineers, right?
Yeah, it was just really cool to see how these tools, because at Pebble, we all knew what we were doing. We all had a mission. But then when me and Chris went to Fitbit, we started building, we started getting them to slowly capture metrics in the right way, or in a way that we found was best and able to scale to 1 million devices or so. There are good ways and there are bad ways to capture metrics, I feel like, so that you can actually do like really, really good queries and get insight into the data. And they didn't really know how the device crashed. I think they got back a handful of 10 registers, and then they had to manually kind of decode those with the symbol file that they had to find them to get the crash. But at Pebble, we had core dumps. And so like I built the web application that kind of ingested core dumps and showed people exactly how the crash was going on. They could click download, throw that core dump into GDB, and like essentially reproduce an issue in a matter of minutes, where like I remember reproducing bugs early in my time at Fitbit, and it was like 3 weeks of work to like play whack-a-mole or reproduce the issue. And so like it was fun to watch these companies slowly transform into using these tools. And I still talk to some engineers there every so often. They're like, yeah, still have your tool. I still use it all the time. I added some syntax highlighting, recently or something like that. And I'm like, yes.
Nice. But speaking about bugs, I mean, like, can you tell us about some war stories in terms of like those nasty bugs that you were chasing back then, or like things that you notice can fail in specific context? So
I call it out consistently, but it's still one of my favorite bugs at Fitbit. There was a developer named Shiva. He was tasked with trying to figure out why so Fitbit was releasing a smartwatch. They were releasing a smartwatch in probably 2016, 2017. And there was one bug that they were trying to fix and track down, where if this device was taken on the Tower of Terror in Disney World, the watch would crash. So the watch would crash as soon as the ride began. And I think it was a customer report or whatnot. And that's the bug report that he was given. I think he was given those 10 registers or whatever, but like you don't really have much information if you just get registers. So he's like, I don't really know. And long story short, I guess the ultimate bug that he couldn't reproduce because it was in the office and not in Disney World was that it was a division by 0 in the step tracking algorithm. And so like when your device is in free fall, the accelerometer X, Y, and Z ratings are at 0. And there wasn't a divide by 0 check. And so there was this like really nice blog post about it on the Fitbit engineering blog, which I think it was maybe one of their only posts about firmware on the engineering blog. It was great. But like those sorts of things would have been easily figured out by a core dump, because you would have seen that these values, one of them were 0, and you would have seen the hard fault register as like divide by 0 error.
Yeah, this is really interesting. Like, all those algorithms are kind of trained to detect, the when you're walking, but then like as you said, like what happens if you are, doing something that's not supposed to be done, like riding on a roller coaster, or just like, bungee jumping, or that kind of stuff. Like how do you?
Or in space,
Or in space.
Yes, exactly.
Amazing.
That was one of the best bugs, I would say, like the most well known within the company. But the bugs that continuously cropped up were the ones kind of outside of your control. New Android versions would be released, or you'd find a new Android phone with a vendor Bluetooth stack that was totally broken in odd ways. Or sometimes the Pebble Bluetooth stack was a little bit broken, and then a phone would adhere to like exactly the spec, and we would actually break, or the Pebble Watch or the Fitbit would actually break, because we weren't expecting that. Like, when packet length extension came out, almost every vendor got it slightly wrong or slightly different, and so like just figuring out all of those bugs was really difficult. And so I think on a lot of times, just because now you have core dumps and you can pull this information, we would actually forcibly crash in certain scenarios, or forcibly capture a bunch of data, and like, sure, the customer watches would be upset for a little bit every now and then, but we'd at least get the data back and be able to fix it more quickly.
Yeah, this is pretty cool. I mean, this is a typical thing that, like, whenever you look out through the stack where you have interfaces between, different components, it's always matter of like, having the right type of interfaces, and like how it's coded on one or the other side. And it's usually like room for error and mistakes and so forth. So, catching those, it's like a typical thing that's happening every now and then, like whenever there's a new thing. So
for sure. And everything is being updated around us. And so like, I can make this perfect little device that has no bugs internally, but if it connects to Bluetooth or LTE or Wi-Fi, I'm in for a world of hurt, as like the routers and the LTE networks change around me. There are so many bugs caused by external factors, and temperature and pressure. I don't know. All these things also cause pretty bad bugs. I remember, same sort of thing at Pebble. It was like, oh, this watch doesn't really work at 8,000, 10,000 feet. And it's like, oh, you got to be kidding me.
It's like the pressure,
the pressure, the microphone had a Gore-Tex layer over it. And if the pressure was too high, the microphone wouldn't really work, or water wouldn't be able to be like expelled from it, or
amazing. This is
more of a hardware bug than a software bug, but
this is amazing stuff. But I mean, this is pretty cool. So this is where what you're saying you guys have been building to make sure that, like, once those bug happens, and they will always happen, there is no way that they will not. How you reduce time from detecting that bug into actually figuring out what is causing it, and then coming up with the solution. Right, that's what you guys are trying to solve at Memfold, right? Or am I
correct? Like, that's a great point. I probably should talk about that too. We are trying to solve, for a hardware company to build a hardware product, you probably need some hardware engineers and some firmware engineers. But in today's world, you obviously need, some software engineers and a cloud engineer to build everything that supports that hardware device. AWS IoT, one of the things that you guys also realize that like needs to exist. You need a path to the internet. You need some sort of cloud component. But you need the software engineers to build some sort of metrics or crash data ingestion service that will then write it to a database. And then you need an engineer who will process all the stuff in the database. If it becomes really large, if you have millions of devices, you probably need a data engineer or two to like handle the amount of data that you're about to ingest and process. And then if you want to make this tool used by your company outside of just like a couple firmware engineers and a data scientist, you probably need to build a like web application and then a front end on top of that. So like, I mentioned it at Pebble, like the support team, all 20 or 30 of them were able to use some of these tools that were written by firmware engineers to like understand how a battery, how all of the peripherals in a Pebble app and how the usage of the watch contributed to battery life, because that was one of our top requests. And so like we had a plotted chart. It wasn't pretty, but it worked. That would allow people to see over time, like, oh, this application really degraded the battery life and they should stop using that. Or it seems like they have their LCD backlight turned on for way too long. They should like tune that down or something like that. Or there was a bug in the accelerometer and like it never turned off. And that's why it was a half a day of battery life. Anyways, you need all these extra engineers and all this work to make the data useful. We are trying to be that sort of platform. We expect that we can come into a company of just hardware and firmware engineers and make them successful, because we provide kind of the OTA, over the air updates. We kind of provide the backend services that would support the firmware updates. We provide the metrics and data ingestion. We easily allow you to collect, metrics and data points, essentially store that into a data warehouse. We allow you to easily ingest core dumps and view how your device was crashing. And then we have a UI that allows, and role-based access control and permissions and all this stuff that allow anyone at the company, support, product engineers, to like use Memfault and gain value from it. And it would have been the dream that we had at Pebble. The amount of times that I had to write, Heroku Python backend code. I still did it at Fitbit as well. But like, yeah, it's just like, it would have been nice to not have to do it.
Yeah, that was an interesting thing. Like, how did this, like, once you mentioned like having all that infrastructure that allows you to kind of like monitor this and so forth, I'm thinking like, what have people been doing before? It's like, but you already said it, like they were building things over and over. Everybody's building it differently, and yeah. So
truly, I believe every company has a version of Memfault. Not necessarily Memfault is the holistic platform that it exists today, but like everyone stores logs in some sort of database or S3 bucket or text files that get sent to Jira. Like every company does. And if they don't, they're also in for a world of pain.
Yes.
But
I do have a question about this. Do you think that there is something like a turning point or something when, let's say you have 10 devices or you have 20 devices and you're kind of fine storing stuff in text files and, looking through or, getting access to the device, having a look. When do you think that turning point comes in where people realize, okay, that's not enough. It's just not going to work out this way?
It's truly like 100 devices, I would say. After 100 devices, it's really painful. But it's also, I guess what we're also trying to do at Memfault is not just make logs more useful. Like the level of introspection into the device that we're actually doing and into the firmware is beyond what most people will be able to do individually. And so, for instance, like Zephyr has when the device crashes and it's using Zephyr will reset and it'll print a core dump, they call it, which is like a number of registers and then maybe like a few hundred bytes of the stack. But like in our world, a core dump is actually like a binary that you load into GDB and you poke around and view all the global variables and the stacks and the threads easily. It's like you're debugging over JTAG. That's our version of a core dump. And so, but that is like, with an hour of work on your firmware, you get the like superpowered debugging mode, not just like whatever you build out through logging.
Can you get like a line in a C file? Like at what point was called and all that stuff? Yeah,
I'll show you. It's very cool.
Yes.
It's very cool. It's like, because we went through the transformation at Pebble, actually. Like, we had the log file, and at the very top of the log file, it would say last known reset. It'd be assert this line. This was the PC was the line, and then the LR was the line that it came from. And then you'd have a few logs leading up to it. And that's all you would have. And you'd be like, well, let's go figure out this bug.
Yeah.
And logs were great for logs are only useful in some cases, I would say. They're very good for like finding out what led up to a crash, but they're really bad for trying to figure out other types of issues and crashes.
The reproducibility. Like I remember, so my debugging experience of the constrained devices was the following. Back in the days with like 8051 microcontrollers, was like a person complained about the bug, and I call him over the phone and I said like, okay, what did you do? I did this. I write it down. I tried to replicate this, fail a couple of times, then ask them again, okay, can you give me more information and so forth, and then bug that person for quite a lot of time until I figure out like, okay, I figure out now what the problem is, and then I send them a hex file via email, and then he flashes back to his device. Like that was the the early days. So I'm super happy like when you're talking about all of this doing remotely and so forth, and the technology exists nowadays to do it. So I can imagine how people are using it. So
it's fun to talk to the customers like that, but it's not scalable, I would say.
Definitely not scalable. So
yeah. And Alina, back to your point, like when is all this useful? Like it's also not just logging as well, like over-the-air updates, like trying to figure that out. We've talked to people who will throw a firmware binary on S3 and then give it a URL, but that means you're updating all the devices at once. You probably want to have a like internal cohort and a production cohort, and then maybe have your CEO on a random build that doesn't crash. But like building that sort of server to just handle like over-the-air updates is also like non-trivial, I would say. It took us a while to build that at Pebble. There are so many things you can kind of benefit from if you just start out with a lot of these tools. And also like if you're building a mobile app or a web application, like you don't add these monitoring tools later. They're kind of step one. Like all the boilerplates, like you load up a Django app or a React app, and it kind of has all of these things built in already. It's not like you add it when you're deployed to 100 servers. We kind of feel the same way should happen with hardware.
Yeah, no, absolutely. I mean, I think there are various ways in which engineering teams can look at things, but it's becoming clearer and clearer that you need to set up the non-functionals as well in place. You need to put logging in place, tracing, making sure you get all the right metrics. It doesn't matter what kind of application you have, be it a web app or be it just a distributed application or be it IoT.
Yeah, definitely.
And a lot of these things exist for local debugging. Like I went to Embedded World, and a lot of the talks were all like, well, literally every vendor there. I'm not gonna call it any vendor's my name, but every single vendor there was basically about how to do things locally, or at least debugging and monitoring tools. It was all like, here's a new piece you can plug into your processor. Here's a new debugger. Here's a new local test or unit testing framework or code checker. Like everything was about pre-production and pre-sealing the unit and pre-deployment. And like we're just like, hey, we specialize in like, I guess pre-deployment in some ways, but like mostly like remote monitoring. We assume you'll have bugs. Every vendor there assumed that like you could remove all of your bugs before shipping. We just know that's not true.
Yeah, I mean the thing that was kind of like really interesting on the embedded world from my side was like everybody's talking about this, software defined IoT, software defined vehicles, all that kind of stuff. And if you go in that direction, then if you don't have a strategy of like remotely debugging those devices, then you're setting up yourself for disaster, right? So that's definitely a must, as Alina mentioned, on kind of setting that from the early stage.
Yeah. I mean, it's the example that you gave, Tyler, as well. I really like that. I mean, when your devices are out there with customers doing crazy things or even not that crazy things, still it's not like in your lab. It's not what you're looking at when you have, 100 devices in your lab and you're testing with that and everything works great.
Yeah, the thing that we had this discussion on Better World. The thing that kind of like changed my mindset completely. What you said there is that before in the constrained devices, you will never put like asserts and that kind of stuff in the code. But like with this thing is like, oh, you should actually put asserts all over the place, because then you have greater visibility of like what's happening with the code. And I was like, wait, that now makes sense. It's a completely change of thinking for the embedded guys. Like, yeah, this is really cool.
This is one of my most fun, I think, presentations that I give as well, or like topics that I talk about, things that I really enjoy talking about. Yeah, like firmware developers never liked asserts because, well, one, they never admitted they liked code, or like they had bugs in their code.
Yes.
And so if they didn't have asserts, they would never really find them. But yeah, like if your device produces no information when an issue is hit, why reset? Like there's literally no point. Or there are points, I would say, but there's no point to like solving the issue, right? But once you have all of the data coming back in, and if the device resets or if there's an assert tripped, you will be able to very quickly reproduce, if not solve the issue within a matter of minutes, depending on how quick the pipeline back is and how quickly you ship firmware. So in my opinion, there's no reason not to assert, because you will likely find a lot more bugs, even with testing on 10 devices internally or 100 devices internally. Because when you ship it to 1,000, 10,000, 100,000 devices in the field, like these bugs that you may not have found will be hit constantly. The 1 in 10,000 hour bugs were like, a single developer will never come across one of those in an entire year of development, but like 10,000 devices in the field, a customer will hit it immediately.
Yeah.
Oh man, the amount of times we'd watch Reddit after deploying a firmware update on Pebble. We watched Reddit like a hawk, and they would find all of our issues.
That's pretty cool to have like that feedback over Reddit. That's pretty interesting.
One of the pros and cons of having a very developer focused community from Pebble was like Reddit. People were all over Reddit trying to.
Yeah, but again, it's like this is mind blowing. I remember back in the days, like we were setting up for scale some systems. And then we had like started with Kubernetes, and then, started microservices, like all that kind of stuff. And then people were saying like, oh, we should actually start debugging in production. And our QA team was like, no, what are you doing? Like you have to have like staging, like dev staging, all that kind of steps and steps in between. And then people were like, no, wait. If we have good tooling and observability, we can actually, debug things in production. Which makes more sense. And but like if somebody told me back then like we should do that for embedded like constrained devices, I would say like there is no way you can do it. But like now what you're mentioning with this asserts and everything is like mind blowing. So that's really an interesting concept there. So I mean, have you seen this kind of paradigm change now with like debugging issues in production and even on the embedded devices? I guess you've seen it now, right?
I for sure see. I mean, we used it at Pebble, not necessarily like, I would say we didn't really know what we were doing, but yeah, like we'd have customer reports saying this particular phone model doesn't work, or this particular feature doesn't work, but there was no way for us to instrument it. Or like, maybe it was a phone that was manufactured in China or India that we couldn't find. We couldn't get one. We had a drawer full of these phones that like we would test on. But a lot of times we couldn't get our hands on a lot of these things. And so we'd add a little hook that says, if you're this phone model running this version of Android, and there's a random number in there, so 1 out of every 100 times, just go ahead and crash and like send us the data. So like we wouldn't ruin a customer's experience, but like every so often they'd get a crash, but it was basically us collecting data from their devices, so that we could solve their issue. But you only needed like a handful of these devices in production to get the data that you needed. So we did that all of the time.
Really, really mind blowing. Yeah.
Or just like, we assume no one will ever, hit this 1,000 times, or we assume that no one will click a button, more than 10 times a second. And so we just assume that it's a bug, or we assume that this queue will never be full. That's more of a firmware side of things. Or we assume that our mutex lock will never take longer than a second. But sometimes it does. And we actually just are very curious about what's happening. Like what was blocking the processor for a second? Why did this thing get get full of a queue, or why did the queue become full? And usually it was because like a new iOS update pushed out data a lot faster, which we didn't expect. That was usually what would happen, or like, I don't know, the latest iPhone would be able to push data faster.
No, this is awesome stuff. Cool. I don't know. I'm actually eager to see that demo. Like, how do you actually, do this? Like, I'm looking forward to that. I don't know, Alina. Do you have some questions before we jump into that, or?
I think we should just jump into the demo and then leave the questions for after, because I'm also really curious.
Yes.
Yes.
Let's
Perfect.
do it. Okay, so let me add this here.
Great. So a quick overview. So what you're viewing here is shuffling around. All good?
I think this view is better.
Great.
Or?
Great. This works. Yeah, this will work for me. So what you're viewing here is kind of the landing page for Memfault. This is what a firmware engineer, product engineer, support engineer would kind of come across when they load up Memfault. And kind of what we're assuming here as well is that the device, and so I'll keep using kind of a smartwatch as an example, because it's what I can probably speak to best since I did it for 5 years. If your smartwatch has the Memfault SDK kind of built into the firmware, that SDK, if you instrument it, will start generating data. And if that data makes it back into the Memfault system, then we start showing all of this data. That data that gets extracted from these devices is usually metrics, and it's core dumps, and we call them like heartbeats or pings, just to say like, here's my firmware version, here's my status, a few other things. And so kind of from all of that data, we're generating these dashboards. And so we will give you kind of how many active devices, what current software versions are actually running, and what is the distribution. Very important for consumer devices, because not everyone wants to update all at once. And so this was actually incredibly useful. This is kind of what you're viewing during rollout. And then down here, the two more interesting things like debugging crashes. And so now we have, these are the top issues. And so these are actually top crashes that are happening from the devices in the field. Some of them are an assert, a watchdog, or a Memfault, are the three we have here. So we can dig into those, and I'll click on those in just in a second. But the other great view that I wish we had at Pebble, it basically came in the form of a SQL query. But like, what are the top reboots? How are the devices resetting? Sometimes it would just be due to the user powering off the watch, or the user actually clicking reboot. But a lot of times it's a hard fault, or it's a watchdog, or it's an assert, and you're actually trying to track the number of reboots and trends over time, given the number of devices in the field. So that's very cool. But let's dig into actually an actual crash. And so we talked a lot about core dumps and being able to see all of the data that came from these devices. And that's kind of what's happening what's happening in this view. And so this kind of looks like what you would see in a debugger, I would say. You have your stack traces. And so for every single one of your threads, you have this stack trace, and you have all the information you can possibly want from them. If I go here and click on local registers and locals, for every frame, you can actually view the local variables that were actually happening. Let me see. Yeah, you actually have the values of the local variables for the threads.
Nice.
Here we'll also tell you and decode the hard fault registers. Like, how did the actual watch crash? The alternative to having this kind of in the UI kind of decoded for you is to open up the ARM spec manual for the Cortex M3 or the M4 or the M33 and try to figure out if this bit is set, that probably means this. But we just kind of code it in human language. Usually what we did was we would write a GDB script that would kind of decode this for you in human language. But this is nice.
And I assume you have to say like, okay, this is my Cortex M0 or something like that for the device.
We actually automatically determine it for the most part. And so like if you compile it into the SDK, we'll know which chip you're using. And,
nice.
There is at least some flags there that you can set kind of at build time, and then you never have to worry about it again.
Pretty cool stuff.
Yeah. It's a great crash. It's actually a Stack Overflow. We can detect that because I think it's built in on FreeRTOS, and it's built in on Zephyr, and it's built on a few other platforms. But like all the data that we wish we knew, I think it used to take us maybe like a day or two to realize a Stack Overflow happened.
I guess it uses like
some of those crashes.
It uses like the MPU and basically, yeah, you can detect if that goes over or something, and then.
Correct. The MPU is kind of a new way to do it, I would say. There's also, I guess, newer ways to do it. There's like stack-based sort of protection registers.
Right.
The canary you can write over for like 4 or 8 bytes. You can write a known value, and every time you context switch, you check if that value was overwritten. There are
like
a number of different ways.
Dead
But
beef
my
or coffee or something like that.
yeah,
I
exactly.
remember those days.
Oh,
Yeah.
yes. Absolutely. We always did. Yeah, we did. I think dead DEAD was ours. So this is all cool, but my favorite feature, I would say, I'm going to zoom out just a hair. My favorite feature of this whole thing is, so you have a core dump, you're pretty much just capturing memory. And so from that memory, we are reconstructing, the threads and the stacks, but we also have access to the global variables of the entire system. And so you can actually expand across, expand all of these variables and see the actual values. And so if your device has a very large global data structure that kind of shows a lot of data that's going, like what data that's going on. If we're a smartwatch, we may know the phone we're connected to. We may know all of the items that are sitting in the queue. We may have our logging buffer or a large array. Like all of that stuff can be viewed in the browser without a debugger, which is amazing. And then you also have, the memory viewer on the right. So if you actually have memory corruption and you're seeing dead here, you know that something is wrong.
Nice.
Yeah. So that's the crash view. This is a crash that came from a device. Of course, it's a demo instance. But in the real world, you would probably see recent traces, like the number of crashes we've gotten devices impacted is the number of unique devices that have actually experienced this issue. And you can page through all of the different crashes that have taken place and all of the ones that are likely very similar to this crash. We kind of group them together based upon some heuristics, but it's mostly crashes that look like each other.
Nice.
Yeah. Go ahead.
I see you have like a fleet and all that kind of stuff. So is there a notion of like different type of devices as well? And like you can do some queries on top
exactly.
of that? Okay.
So because we have kind of all the devices pinging the server as well, we know roughly all the devices that are out in the field, what software version they're running, when they were last seen, what cohort they were being deployed in, and also like based on those cohorts or based on device attributes or what's going on, you can kind of deploy certain firmware versions to them. So let me go to another kind of project here. We can go into one device. So let me go into, we have certain ones. This one's a good one. So this is like an individual device. So if you're a customer support person, now you can go into a single device. So we know how it's built, we know what hardware version it is, we know when it was last seen, we know its software version history, and so like this is the software version kind of history over time. And then these are all the metrics, and so this is the kind of view that we were using at Pebble to understand battery life drops. And so we're measuring, we typically recommend customers, and we're doing more by default, but like how long the CPU is on versus off versus in deep sleep mode, how long the Bluetooth radio was on, how long the accelerometer was on. And all of these values are typically in like per hour increments. And so if you see a big drop in battery percentage, now you need to figure out kind of what other metric had risen that would correlate with that battery drop. And so that's what this view is trying to solve. And then you also, this is called timeline, but you also have all of your crashes and all of your individual instances of an assert that you can kind of dig into and then go into and kind of debug itself. And so this is great for I would say, customer support.
Yeah. The thing that I'm curious, and I think we did talk about this before, like, is there any open standard or like a protocol or specification that you guys use to kind of, package this data from the device to like wherever it needs to end on the server? Or you're having some kind of like, you build out your proprietary thing and that's it?
I mean, it's not, I wouldn't call it proprietary. Proprietary means like it's our secret sauce, I would say. Like there was no open standard for So for a core dump, for instance, a core dump can range anywhere between a couple kilobytes of code or kilobytes of space to the entire RAM size. And so, I don't know, 200 to 200K to a meg. Trying to send that over Bluetooth, you need to, packetize that up into 20 bytes. And all of those data packets need to eventually get back to our server. And so we built something, we call it chunks internally. But that data gets basically chunked up. And then we have a server that basically then would stitch the data all back together. But like trying to send data over 15 byte increments is not something that the web is really built for, or like the world in which we know it today. And if we dreamed of using open telemetry, like one log file is probably the amount of space of a core dump, and so that's not really something we can use either. And so we built a lot of it ourselves, and a lot of the standards and the way that we do it is open source. It's on our GitHub.
Mm-hmm. Nice.
Okay, nice.
Yeah, this is really interesting.
I think you're muted, or I can't hear you.
Can you hear me?
Oh no.
Can you hear me,
You're
guys?
static. I can now. Yes.
Okay. Sorry, I might have lost my connection or something. So no, what I was saying is like this is really interesting because I think maybe this is we were talking about this earlier, even Alina and I, just before this call. Like we are looking at this from the whole stack perspective of like you have your microservices. And you have like edge devices that are like capable of running Linux, and then you have your constrained devices. This is like the overall stack of like how you look from the IoT perspective. And there is a piece that it's missing in terms of like a unified standard or like how you would monitor across the stack. I mean, again, for like edge Linux devices, you can still use something like OpenTelemetry, but it would be really interesting to see like maybe inspect this further when it comes to like Memfold and what you guys are doing, and kind of plug that into like this overall stack. So if you look from the high level of like, how your IoT stack might look like, to have that kind of observability as well embedded. And that brings me to another question is like when data is being sent, like how does that relate to like, let's say the customer has its own AWS account, and then it needs this kind of front end and so forth. Like, where does the data go? How does that?
I think I need to change my Wi-Fi network, which I'm not pleased about right now. Will I lose you if I change it real quick?
Let's try it.
Okay, 1 second.
I mean, is my network okay, Alina? Do you?
Yes.
We're gonna see if I can do this real quick. Oh no.
Yeah, I can hear you just fine, Nenad.
Okay.
So it's all good.
All right, I'm back.
I think we're
very good.
Oh yeah, this was non-intrusive at all. So
seamless. Really great.
Oh come on.
So not sure if you understood my question, but yeah.
Honestly, Nenad, I can barely hear you.
Okay, what about now? I'm going closer to the microphone. No? Alina, can
I'm
you
gonna
hear
try
me?
to restart this browser.
Yes. Yeah, I can hear you just fine.
I think it's
so
this issue like over the ocean is there. So.
Yeah, I think we lost Tyler for a second. He's gonna probably be back. But yeah, I mean, I think it's going to be really interesting to pivot the conversation towards open telemetry, because I'd like to understand, what the challenges are there. Getting this collection in open telemetry format, and getting this sort of agent collecting data from, let's say, FreeRTOS devices or, non-Linux.
I'm back. And you sound so
Hi,
much
Tyler.
better. Sorry about that. Very, very apologetic.
No worries at all. Yeah, I guess the question Alina just mentioned was that like looking from the high level perspective is like we need a unified observability for the whole IoT stack. And in the IoT stack,
Yes.
you have like services that are running in the cloud. You have services that are running on the edge, which is like, again, some Linux based operating system. and then you have like those constrained devices, and then we want to monitor like all of those and have insights of like what's happening. That's the one question. The second question was more or less, yeah, we can come back to the second question. So let's start with this.
First question. We've seen there's a dividing line. I think most of the services out there today monitor software, and that software has no dependence on hardware really. Hardware kind of influences it a little bit, and so like if you're monitoring a mobile app or a website, like yeah, you maybe care that it's running on a piece of hardware, but you generally don't. It's generally on a server. Doesn't matter if that server changes overnight. You're just monitoring a piece of software. What Memfault is trying to do, and why we're different, and why it's actually, like, I would say, better for IoT, is because we actually are trying to monitor the firmware that's running on the hardware. Like, it's actually baked into hardware. Usually people are supporting a piece of hardware, whereas like I think a lot of software companies are supporting a website. They don't really care where the data center is. And it's especially hard to use a lot of the tools that exist today if you're trying to do monitoring of millions. And so if you're trying to monitor a million services, pieces of software or something, like the data model doesn't really work, doesn't scale, especially in cost, especially by cost. And then the amount of data that you're going to get is astronomical as well.
Yes.
Okay. So would you actually say that OpenTelemetry just wouldn't work from the perspective of the format of the data, like the schema of the data, or is it the collection agents that are not really compatible to run on certain devices? Where would you say the challenges lie?
There are a few challenges. OpenTelemetry would not work for the constrained devices. So like a massive JSON blob would barely fit into the flash chip on a Pebble watch, even if you wanted to store like one set of logs. And so that just won't work. For embedded Linux and maybe for Android, which we support as well, like OpenTelemetry is at least a little bit more common there. The other reason we found that OpenTelemetry doesn't really work super well, at least the format may, but a lot of the services that ingest it don't really allow old data. We work with a lot of devices that only connect to the internet once a day or once a week or once a month. And a lot of the services that are built today don't allow late arriving data. And they don't allow because all these massive data warehouses have to compress the data in any particular way. Anyways, they aren't built for late arriving data. You assume that all the services today assume that you have like up to a second sort of data connection to the internet or something immediate. We try to allow data at least from like 2 weeks ago. And so if a person goes on vacation and then comes back and their smart watch wants to send, or smart lock wants to send a bunch of data because they were on vacation, like it can do that. We'll ingest it and then we'll show that on the timeline from 2 weeks ago that like something took place.
Yeah, this was one of my favorite aspects of OpenSearch. I've always loved OpenSearch because of the way you can just ingest the data with a timestamp. It will just put it at the right location in the index. No trouble, all good. So yeah, I really liked the way it handled data consistency.
Yeah, interesting. I mean, this is pretty cool. And the second question was in regards to like what you're saying. For example, the front end that you have is, has to be running somewhere. And my question was like, if you have those devices that are connected to like customers' account, how do you present them with that front end? Like, where's the data going through? Does it need to go to the servers that like are in your account, for example, or like how does that work?
Yeah, I mean, like I guess we run as a standard SaaS company. We have a set of servers running in AWS, and so most customers, if not all of them, will send data to our set of servers to our endpoint, and then we host the front end. People will log into memfault.com and kind of log into their application. All the data that people send us is encrypted with their own project key. And so we try to slice and dice and separate the data as much as possible. But the management, it's much easier for us to manage the server and scale it and secure it all if we have basically one instance. Yeah. No, that makes sense. No, this is really like interesting conversation. And I feel like we just started the conversation, to be quite honest. Like
I think we have like 10 more minutes. So anything else? You wanted to cover? If not, I have other questions, but yeah.
I guess, are there questions from the audience or maybe not? But yeah, I think let me see if I have anything else to cover. The funny thing with firmware in general, and this is something you can probably touch on as well, and from your past, not much is shared amongst the community, I would say. Like, we have done a really kind of intentional job of sharing what we've learned over our time in firmware, and that's through our blog, interrupt.memfault.com.
Yeah, let me share that one. I really like. I kind of, once you mentioned it, I started looking at it and reading things, and it's an amazing source of information. So let me put that in the comments here, so that people can review it afterwards. But yeah, go on.
Yeah, like, has that, in your experience, I guess, as well, even working at AWS IoT, like, I very rarely will see people posting, I guess, production ready code or ideas. It's mostly like Hackaday or like, here's a quick 0 to 1 proof of concept for firmware. But, you know, I think the next blog post I'm going to write on Interrupt is like, here's how to correctly, I guess, measure and ingest, store and present battery life data for when you have over 1 million devices in the field.
That's cool.
Because you can track it incorrectly, I would say, and you can make that query incredibly expensive to run, and it would take a week to run, which we kind of had at Pebble. Like, we did it both in a bad way and a good way. Or you can build the measurement in a query in a way that, like, it would take a few seconds to run. But I want to present best practices to people so that they get started on the right foot rather than the wrong foot. But I don't know who else would write that post if it wasn't for us. And I'm curious, like, do you see that throughout the industry as well? Like, the lack of sharing?
Definitely. So the thing that, at least I noticed, but is that things that are above the, let's say, starting from the Linux kernel and above it, in terms of like devices that can run like this bigger operating systems and applications on top and all that, there is a bigger community of developers that are willing to share this information and create meaningful projects. But like you're completely right. When it comes to constrained devices, the overall community is a bit more closed. So you have, like companies like Garmin and I would say Pebble and like Fitbit and all those that I've seen in the past sharing information, but like not to that extent as you would see it with this kind of like open source movement of something that's built on top of like Linux. So yeah, so this is really interesting, to see kind of from your experience and putting this thing in this kind of blog format. It's pretty cool.
Yeah, I think I've concluded that it probably comes from the fact that, like, most of the software that people run on these devices generally was proprietary. Like, FreeRTOS was the exception to being open source, right? But like all of the other ones were closed source for a while, and so it was like, well, if I can't even share my like Hello World application because I had to pay a license for this software, like, I can't share anything. So what's the point? And that's not quite the same in software, where like almost everything up and down the stack is open source.
And even in that context, like, you would mostly have either like bare metal applications that do not, have operating system, and extracting something in that context and then sharing it is quite hard because like, you do with the registers and whatever not. And then even if you have something that's running on the real-time operating system, in most scenarios, there has been a lot of, and also in my experience, there has been a lot of like proprietary operating systems that like guarantee real time and whatever not. And then having application abstracted there and kind of demonstrating it to the field is not so easy. And it doesn't make, like, it's really hard to present in a context outside of that operating system. So I think that made it really challenging. But the good thing is like with this Arduino stuff, I think, you know, at the early beginnings of the Arduino, it was like, oh, just hobby projects and so forth. But, you know, I think I'm seeing more and more, people taking this to the production as well, even though it starts as a hobby. But yeah, to some specific scenarios, people are taking this further. So I'm hoping kind of that community to start sharing more and more, because it's like a unified platform where you can build things on top. So let's see.
Correct. And especially Raspberry Pi as well. Like
Exactly.
seeing people actually build products on top of that and then publishing their learnings about deploying Raspberry Pis at scale is very interesting.
Yes.
But yeah, like the amount of times that I will write a blog post about using asserts in production, and then, you know, I'll get a few people every now and then, they're like, oh, we did that in the 90s, you know, like I'm like, and where is that information, or
Yes.
you know, that sort of thing. And it's like, it's not like what we're doing is unique, it's just like, I guess it's unique that it's being published and being, I guess,
Yes.
productized in some way.
Yeah, exactly. Okay, cool. Alina, you have any questions?
No, not at this point. I mean, this has been a really interesting discussion, and I particularly enjoyed the demo. So, you know, really interesting stuff. I'm also very interested in general in open telemetry, and how we can actually leverage the standard more and more, also for IoT solutions. So yeah, it's been really interesting.
Yeah, excellent. So then I don't have any questions. I think where can people find you? Like this, let me put this, it's like just memfold.com.
Yep, exactly. memfault.com. I would also say, like, you know, if you're listening, you're probably into embedded firmware development or something related to embedded. The blog that we write on, interrupt.memfault.com, is where we kind of dump all of our learnings over that we've had over time, and it's where this it's a forcing function, but it's where this, like, for instance, how to measure battery life for millions of devices, that's where that post will, like, eventually go as well. Not on the Memfault blog, but on interrupt.memfault.com.
Cool. So I shared both of those for the people
got it.
interested. And yeah, I think that's it. Then that concludes our session today. But as I said, I'm quite interesting to discuss this further. So hopefully, you know, at some point we had more opportunity to chat about this. But yeah. Okay. Then yeah, this is it. Thanks everybody for joining us. And then see you next Wednesday. Thanks, Taylor. Thanks, Alina.
Yeah. Thank you, Nina.
Thank you.
Thanks, Alina.
Thanks,
Thank you.
Tyler. Thanks a lot.
Cheers. Bye-bye.
Cheers. Bye.